Okay, so we're live. Let me do the pop-up here. I'm going to put this pop-up over there, such as you can see the chat here. I have a problem with my OBS. I always have to reconnect with YouTube somehow. Hey, Step. Thank you, Step and Xvoid. Awesome. So today here, the episode 4 here of building the Zcoder, kind of live. And we're going to do the event model, finish the event model of what we did last time. I mean, do the first kind of part. And that was something very interesting yesterday. It's in a way, it's a power of Rust, and sometimes a little bit frustrating. But when you find out, it makes total sense, and it's actually very good, because then we can do concurrency and being completely safe, and we don't have to use unsafe, without pun intended here. And then the next one, we are going to start our data store, V1. I don't know if we're going to use the SQLite yet, but we need to split our TUI state, our data, from our state. And again, we're going to look at that, but basically the loop here needs to be, the TUI state is only what we see. And the loop will try to gather from the store only what's need to be displayed in the UI. So by doing that, then it's much more efficient. And so we split the state from the data store in a way. And so that is very important to do that. And again, the goal here of the Zcoder is to be done kind of as that would be the architecture here. So that is a multi-crate, but the point is we have a UI here, which is the ZCTUI. I forgot the C here. That is the ZCTUI crate. My screen is over there. That's why I'm looking weird. Okay, so that is a ZTUI, which is a TUI. The ZC core, which will be the core where we're going to have everything right now. And then we might split that layer. And that is a common thing that are common to both kind of utilities and event model and everything. So the event was there. And eventually we might have a ZC web, which will be a web view of the terminal. So every terminal will have their own kind of view. And all of that is in Rust, obviously. Let me pull the cool Rust logo, because Rust is awesome. We're going to put that there a little bit smaller. So first, what is Zcoder for the new guys here? So the Zcoder, I'm going to do a very quick one. And if you have questions, feel free to ask in the chat. The Zcoder is this one, zcoder.run. And basically, it's going to be a parallel first AI coding harness. So it has the concept of workbench, which I'm already using in Procoder. So we're going to see that. So there's already a tool that I'm using, which is workbench-centric. But the goal of Zcoder is to be able to have multiple workbench working in parallel within the same work tree. Only one can write into the work tree, but the point is you can even work in parallel. And then you can even spun workbench into another work tree if you want to. So that would be the goal here. So it's going to be very, very powerful. And one thing I'm doing is I'm starting it from scratch. It's going to be open source. It is open source over there. And it's going to take a lot of the goodness that I have in my AIPack runtime, which is kind of a generic pack. And within that, I have what I call a Procoder, which is a pack which allows me to do Procoder, which is also workbench-centric. But the goal here is to package all of that into one runtime. So many of the AIPack goodness, the Lua and all of that, SQLite and everything, we are going to do in Zcoder. So in a way, Zcoder, we're starting from scratch, but we have like a year and a half of solid foundation that we're going to port over in a very careful way. So that is the goal of the Zcoder. Okay, so I'm going to do that like that to not confuse. And I'm going to do Substack. I'm going to start posting one of those days. So now that we have this, let's go back to the code here of what we did yesterday. And so yesterday was a very good session. So what we did yesterday is that. I'm going to show it there. You know, it's this guy. That was episode 3. We did a workspace. So we have these 3 workspaces that I shown, the subcrate basically, and that is to scale code. And so usually I don't do that too early when I start, but it was a good time to do because I had the hello world in a way working with AI and everything. And then it's good to do that sooner than later. In AIPack, for example, it's 1 crate. And because it's 1 crate, it's a little bit too monolithic in a way. So that is a very good thing that we started like this early on. Then we went to Crossfire. Crossfire is an awesome MPSC, MPMC, and all of this kind of goodness. And because it's so efficient, they've done it the right way. And sometimes it can get a little bit trippy or finicky to use. And it was a me problem. It was not a crate problem. And we fixed it thanks to, by the way, Xvoid here. That thanks a lot to give me a good cue. I kind of fixed one, and then there's another issue. I'm going to show the 2 issues that I had. That thanks to Xvoid kind of put me in the right track, and then we had a good pattern. So it kind of made sense, and we're going to go over that because it's actually pretty cool the way it's done, and that is one thing of Rust. It's a benefit of Rust. So we're going to dig into that with async and sync and send and all these kind of things. And so today here, what we're going to do is we're going to do these 2 guys, event model and data store. Okay, enough talking. Let's go coding. So now we have those 4 guys. That is 3 guys. So 4 with the source code. Sorry, here, there's a little guy over there. I don't know what happened. And we have this source here that is Zcoder, and then the 3 subcrate. So we have the ZCTUI and the core and the command. The core is the one that is doing the job. Right now it has executor. Things are going to be split in more parts, but right now it has an executor. So if I got. So now if we go there on this one, and I'm going to do a cargo run, and that is Zcoder today. So very simple here, nothing, but the goal is going to have workbench over there, and that is going to be pretty nice. So right now, for example, if they say y is sky blue, then it will send to the AI, and the AI will get that. So that is a TUI. Everything is kind of responsive in some ways. Right now, there's no scroll. I'm going to add the scrolls. And we basically have 2 main loops, one for the executor, and then one for the terminal UI, the ratatouille. That is the way it works. So now, if we go here, we're going to see the core, which has the executor loop. And then we're going to see the TUI, which has the TUI loop in a way. So they are done in a little different ways, but it's the same, similar things. And then I have this pattern here, which is the TUI RX, TUI TX kind of thing. So that is type alias. And then I have the loop here that I go and I make sure that I refresh the terminal. And then in the implementation, I have a thing also when I start the TUI, okay? I have the new multi-producer single consumer bounded. So I don't put a bound because this is my APIs that I normalized into the Z command. This is command. So that is my event layer. And there I do my types, which is the TX and the RX, that are wrapping whatever libraries I'm using to do my event. So before I was using Flume, now I'm using Crossfire. So if we go to Flume, crates, so this one, I was using this one, which is very good. I mean, as you can see, it's like top notch and still good to use. I mean, if you're using it, don't change it. I'm starting from scratch. So my AIPack is using this one. I'm not changing anything. This one I was starting from scratch. And then at some point, I think he's saying maintenance, okay? Casual maintenance mode. Now, that is not a hard maintenance because the developer still maintain it. So you can see the version here. This one was 5 months ago, completely fine. And it's very robust. So you can use it, it's no problem. But now we're using that one, which is a Crossfire. And this one is starting in a way, kind of a new guy, but I think he's going to go pretty fast. And he has a very good cadence right now. It's very well used. So it has really focused on performance. These guys really know what they do, obviously. And they all have this optimized SPSC and all of that. And all of those types are very optimized on what they do. So then you have different types sometimes, which is a little bit tricky, but otherwise it's very well done. So I'm going to normalize everything in that. One of the reasons why I like Flume or this one, and perhaps Canal does it or Crossbeam, I don't know, but one of the reasons why I like these two is because of that. When I wrap it, I have the TX, it's mostly for the TX, where I send, and I like to have the TX by default async. Okay, so that is what I'm doing here. I'm wrapping the TX, which is the M async TX. So in my code base, I want TX to be the multi-producer by default, and RX to be single consumer receiver. So that is my default mental model for a lot of things. That's the way it works. And then if I want to have other things, I will have other types. But that is my types that I'm going to use everywhere. Now, the trick is that Crossfire use also these names, but then I will use mine in my crate. And then the thing I love about this pattern and this crate is that when you're on a send mode, what you can in a TX, what you can is you can send normal business, okay? And then you can also send sync. And the way it works in Flume is a little different. They have, you just say send async. They have also the opposite way, but that's fine. On this one, you need to clone your TX and you do a into blocking, and then you can call the send. So that's fine. But the nice thing is from a surface standpoint, in all of my code base, that is a way to go. Yeah. This is a transmission. Yeah, this is very cool. So that is a message passing in Rust. And this message things allows us to have multiple loops, and they can communicate in a very efficient way. So when you want to do, for example, a TUI loop, and then you have another loop that want to run, that is what you are using to do all of this concurrency without calling async everywhere. So you put message passing. Same thing in Go. A lot of Go's was like that as well. And if you do web workers, and sometimes you have that as well. So that allows us to have sync. So sometimes when I am in an async function, I do that. Sometimes when I am in a sync function, I do that guy. And everything is going to work well. There's a try send that I'm not using that much. And then there's this one, the receiving. So I'm going to wait until there is a new event. And then the try receive is very nice because it's going to try it to get it. And if he gets it, or if there's nothing, it will return an option. So here I changed a little bit the type that Crossfire sent, because me, I like to have option is not a failure. Option is like, well, they were not, you asked me to watch, to pick, and there is nothing. So I give you none. It's not an error. And then otherwise, if there's one, there will be a sum. So that is the way it works. So I kind of normalize again this library, Crossfire, which has made this call is fine. Just like for me, I like to have this pattern. And so there's no right or wrong. I mean, on this one, I think it's better to have option. But often it's just about how you want to normalize it across all your applications. So that is a way. Now, the way that that is working, there's something. So now we're going to go pretty deep in Rust here. And yesterday we had 1 hour here where I was like battling myself and getting confused. And sometimes it happens in Rust. So I had this guy over there. And I was, so it's these guys that were complaining. Yeah, I had this guy and this guy was complaining already. And I couldn't understand why he's complaining. The receive didn't work. In fact, the receive here, if you don't put a mute and you put that, you are going to get these compile errors. And sometimes the compile errors are not. Yes. Okay. That is what threw me out. And somehow, and it's nobody's fault in many ways, but that is what threw me out, and my brain like went somewhere. Yeah. And again, I'm not the boss of my brain, so it's like I don't take responsibility. So then I say, well, cell, I'm not using cell. Why is it cell? And then he say RW lock, and I say, I don't want to be in the business of that because that's why I'm using message passing to not have that. So I got confused. So then after I was like, okay, I'm going to go to my function. So that is mine. And then I'm going to go to the inner guy. And that is, if we go to the inner, that is that guy. Okay. Then it took me a while because this one kind of threw me out. So it took me a while to kind of understand that that was the issue. So offline I went there. And then I understood, I don't know where I understood that because here it doesn't say mute, but I understood from somewhere. I don't even know how I found out. So this one, I was like, well, that doesn't make sense. So then after I did a mute, and I think when I saw an example, they had a mute. So I had a mute and that solves that. Okay, so this one was solved. So then I go back there and there's no issue, but he didn't say, oh, it's not mute. It says something about the cell and the RW lock and stuff. So that's why my brain went somewhere else. Okay, so that's one. Easy peasy, this one. Now, there were another guy, and that is where xvoid saved my days this morning. Saved my morning, I guess. So there were another error. So when you fix this error, then there were another error. And it was a very interesting one. So it was in the executor now. Okay. And then the executor is, we have the executor action RS. So again, it's the same pattern. I like to have my type alias, and sometimes they become hard type here, but this one is type alias for now. And then it goes back to my ZC command. And then that is my RX. So it's the same pattern here. But the problem of that is I had this guy inside the executor, and rather to have the inner, I have everything flat there. So I had action RS and then all of these ones there. And then in my handler, so when I do I create the new guy and I put my action. And again, all of these guys were flat with this. Okay. So I'm going to explain, it's pretty deep in Rust here, but it's stuff. And then I have this guy, which was implementing in the executor guy. And he was doing a self handle prompt. And that had a big error here. And it's like, again, this very similar to the one before, saying, you cannot move the staff cell is not sync, you cannot move it, and all of these kind of things. And then I don't understand because I took the ownership and everything. Well, even yesterday, we kind of found out that a little bit, but it didn't click, at least for me yesterday, is when you go to the RX here and then this type, which is the type of Crossfire. you will see that there's a phantom data. This doesn't store anything. That basically removes the auto trait sync. So the reason why they do that is could be other type here that they could have. They use serve because it's probably a cheap one. So you could use other types that are not sync. And that will make that type not sync anymore. And that is very smart. Again, the guy of Crossfire, they really know their stuff. So when there's an error, it's our error, it's not the crate error. So now this guy is marked as not sync. And not sync means that you cannot use it across async stuff. Yeah? And so you cannot have a type that you use across. You have to move it, and then it's on within this task, this Tokyo task, async task. And so the problem that we had before, if I go back there, and you're going to see I'm going to break it, and I'm going to break it in a gentle way. I haven't tested it, but I know it's going to work. So the problem here is I had my executor, I had my inner, I had the thing and it was saying the error. The reason why is because that guys cannot stay into the self. So let me show you. If I go to inner, and so that is my execution inner. The reason why I've done that is because I want to fully separate the Rx from the inner. Because the inner is sync. Quite sync, it is by itself. So now I can call it the way I want, everything is fine. But the problem is the Rx was not sync. So then it broke it when it was part of the executor. So that's why when you look at the code here, I deconstruct my executor into the action and the inner. Now the inner is fine to put inner handle prompt. That's good because it's sync. And the action array is not sync, but it's not a problem because now it's owned by this guy and it's not doesn't go there. So for example, if I wanted to break that, I'm going to show that. I think it's going to work. If I were going to go to my inner and I'm going to add a TMP example, and I'm going to do that option. So now I'm adding this TMP example over there. And I don't explain, I could explain the thing better, but I'm going even to put a known here. Yeah, because we're not going to use it, but you're going to see. And that, hopefully, should break. There. And now we're going to see the errors that we saw yesterday that I was banging my head. Yeah, this guy. Yeah, bloom, sell, all of that. I was like, what's happening? Why I'm adding a type that I don't even use, that I don't even initialize. I know nothing about it. And now I have an error. That is a question. Well, the answer is not that hard. I mean, it's not that hard. It took a little bit of time to get it. The answer of that is as soon as I do that, because that guy, the compiler doesn't know that I'm using it or that initialize or not. He cannot know it, yeah? So what is going to know? I mean, it's a sum something or not. It doesn't run through the stuff. So what he's saying is to say, hey, you have this type, an option, that doesn't matter, but you have this type within execution inner, but this type is that guy, and that guy has that guy, and that guy is not sync because he had this little phantom data. So now all of that become not sync. And so then this guy cannot be sync. And then I cannot call it like, I cannot pass it there. Yeah? Because, and it's confusing because we get the error, and I'm not saying it's anybody's fault, but we get the error here, which is like, why? Because this should work. That shouldn't be the issue. I mean, here it's even harder to understand because it's the child of the executor. And so then after we say, okay, we're going to go to look at start, and it's like, what's happening here? It's fine. I'm getting this one, I'm getting that guy. This is fully owned. So what's the problem here? But the problem is that the executor, we're moving it there, but then it's across await boundaries, and then it does a thing, and that will need to be synced. So now if I go back to inner, I'm sure there's a better way to explain it, but I remove that. So now this guy can be synced. And now save it, and then everything works nicely. Okay, compiles. Now I have the cargo. So that was the thing. It's kind of a little tricky, and sometimes that is the thing with Rust. I mean, Rust, I think is still, I mean, it's best language by far. That is one thing, and I don't even know if there is a good solution or not in the debug. I mean, I think the error reporting is very good, but this one is a tricky one because I don't know how they could, report it in a more intuitive way. Yeah, it was a root cause, but it was because of the lack of sync and stuff. So that is the thing is where we need to really see if a type is sync or not. It would be cool if when we do, and there might be something here, if the Rust analyzer could tell me this trait, I don't know how they're called, the marker trait. Yeah. It would be cool if they can tell me if this type is sync or send. Yeah. But all of that is, we can say, well, that is annoying of Rust, but that is what allows us to be fully concurrent in a safe way. And that is where the lifetime tracking and so on and the ownership, it's a little bit overzealous, but the compiler doesn't know more. Yeah. So you could go unsafe, but that is not needed in this case. You do it like that. So you make sure that this guy, when you use Rx, you don't want to be part of the type that you are going to pass across async boundaries. So that is a way, hopefully that helps a little bit. And big thanks to Xvoid here, same this morning. And then I had lunch and then I said, oh yeah, that's why. Okay, so now we have this done that. And so again, the pattern here is we have this TX business RX, which is my type. Then there's a cool, yeah, it was an interesting one. Well, I didn't look as smart as I wanted yesterday, but that's fine. Sometimes you have to look dumb in life. So the thing is, we have the send, this is good. We have the send sync, which is great. The try send is not something I'm sending often. I'm going to remove it, I think. I'm going to remove this one. Where? No, that's fine. I'm going to keep it. And then I'm going to remove these two, such as it tell me. So I had this. No, actually, I'm going to remove. We shouldn't keep that code. Yeah. Now, Xvoid also sent me the stuff. I don't like the way I have it there. Is stuff, and I think is TX error, and that is TX error. And that we're going to call that an X error. So usually they don't like this. Rust doesn't like it. We're already in error, so you don't want to do something like that. So you do like that. Okay, so we do that, code clean. We're going to do a clippy. So that is what I do. I make sure I'm going to search for the allow. Oh no, it's not that. That's fine, the ping timer. This one is what the UI state. So I think this one, we can remove that. And then this one is fine for now, probably. Okay, so now I'm going to do the clippy clean here. State processor. So I don't know why this one is not. Okay, so this one. So we're going to work on that next. So I'm going to put this one like that, and then that's it. Okay, so we're going to work on that, and I'm going to do. I zoom out. I use tmux here. So this is what I have, and I call it Clippy Clean. Clippy Clean. I'm going to push it. You have it. Okay, so now we're going to. So one thing I wanted to say the pattern, to fix the pattern. So here, what we're reviewing is we're going to do the code review here from this guy. And so very quickly, what I like to do, and I've cleaned up this morning, I go to event. So I like today, and that might change over time. But right now, I like for every crate, I have events, and that is the event of that crate. So then I go there and I say, okay, there's TUI events, and then this event over there, and then there's a ping event as well. That is a ping timer to make sure that when there's something running, it's still pinging the TUI, such as the TUI refresh. Because you don't want to have an infinite loop on TUI, otherwise it burns your CPU. Burn. Keep running. So now what we're going to do is we are going to go to the ZTUI. So we see that we have the event and we have the type alias over there. And then we have the same thing for the Zcoder, where we have the type alias and then the event over there. And then this one is actually all over the place. That shouldn't be there. I might do a force push, guys. I'm sorry. That is my mistake. Okay, so we go back there and stuff. So that, like this is cool. Now I'm using Z, and Z doesn't support code folding, but I like to have that as well. So right now I have one guy with all these kind of things. Eventually I might have a folder and things, but that is going to be exported as Zcoder event, and then I have this type. So that is what you can see in the code here now. It's kind of clean. And then in the ZC common, same thing. I have event today, and then all of that is flattened out. So it's pretty clean now. I have a nice way of doing event things. And I'm going to do. I'm very early right now, so I'm going to give. Usually I don't like to. This is bad because it annoys people. But right now, I'm simple enough. There's not a lot of followers yet. So now one thing that I want to do here is you can see that when I run the Zcoder, it's going to be ZC, by the way. But when I do a cargo run, you can see that when I say why is sky red, then there's a response over there. Now, the way that the response is today. So right now, what we're doing here, we did a code review of that guy, and we're going to look at that guy. Okay. Now, if we go and look at our architecture, we have that architecture. Oops, sorry. That architecture. So we have these guys over there. And then, in fact, today, and I already started a little bit things, we have the TUI loop, which is going to be the loop that is going to take care of the rendering, with Ratatouille. So this one we want very, very fast in a way. And then we have the executor loop, which is today is doing the work. So we have these two loops, and then it's a send image back and forth. And right now, if you look at the data here, there's going to be a TUI state. Okay, and the TUI state should be the state needed to display the TUI. So far, so good. Now, the problem here is that if you look at the TUI state, and we look at this guy, so right now it has this architecture because it's going to scale more. But what we have is these things, which is we have the new, and here it is, last answer, last error. And is that a good one or is that a bad one? So we're going to see the executor. So when it executes, so that's the new, we don't care about the new. We do the start, we handle the prompt, so that is where. Now we do the prompt, we have the status TX. By the way, the TX, you can pass it everywhere, so you can keep it, this guy is good. So you do a run start, okay, status event on that, and we do a chat break. So that is GenAI, the crate GenAI, so it's a crate also that I own, that I write, but there's so many good PRs on this guy. And then we load the file context, so that is UDFX. So that allows us to load the file context, because the cool thing is I can ask today, even today, and it's just like very early in the code, but I can ask Zcoder to write code. And again, we're on a 0.02, yeah, so it's not supposed to be functional, but we can do that already. And then, sorry about that. Where am I? Oh, that was annoying. Okay. And so that at message, so that is AI stuff. I call the GenAI client, that's great. I get the result, that's great. I extract all the files, so that's the magic of UDFX, that's great. And then I have other content that I return to result. So that is that guy. So that is the content of the AI minus the file change, because UDFX is extracting it. So that is the magic of UDFX, which I'm using in AIPack. So it's very battle tested, even if there's a very low usage. And then if I look at the result, if there is a result, I send to the status TX that data. And so the whole answer. Okay, so this is bad. Yeah, and it's bad in UI as well. You're not supposed, I'm going to take a strong man here. If you want to do scalable system, cloud or client desktop is the same thing. And I'm going to say something weird that a lot of people are going to say, what, are you crazy? You don't send big payload data in your messages. Yeah, you try to avoid. So in this case, it's a little bit different because we're in memory. So that could be fine. But the way here is we don't want that to come to the UI. It's not really what we want, because otherwise the UI is going to have all of these big events coming to it. And it's not what we want, because we want the UI to say, hey, I want to listen when something changes in the data, and then I want to decide what to look for, because what I need to display. So here we always send that. In the case of, for example, this UI, which is the AIPack procoder kind of stuff, that is AIPack. Here, when I'm here, I don't need, when I'm here, I don't need to have the overview data. Or I don't need, actually, when I'm on this task, on this run, this is runs, and that is another run, that is another run. So when I am clicking here, I don't need to load all of the content of all of these runs. I just need to have just the name there, and then that's it. And then the UI is going to keep that. So when I'm going to run an AI and it's going to run later, what I want is the UI, the TUI to receive event when there's new data on the server, such as it can decide if it needs to grab this new data and do something with it, or blink or something like this. What I don't want is I don't want the message and the whole payload to go back to the UI. Because then if someone else is listening to the same guy or want to see the data as well, then what does that mean? Does that mean that you need to subscribe and then get all of this payload as well? And then you need to duplicate the payload and put it in Arc, and then it's open. Like it's a Pandora box. And then if you do that in the cloud, in a distributed environment, then the problem is, then it's like, oh, I need to have a message bus that scale, let's go Kafka and everything. And so then suddenly, because your payload is 10x, 100x, 1000x more than what they should be, then you have to solve this problem. So what I want is, I want this executor in a way, and there's kind of a runtime. There might be a message in memory to send that to one guy, but then I want kind of this core to have a store, such as it will store the things, and eventually it will be in SQLite, because that is scaled very well, and that is what we're using for AIPack, which is another runtime. But this way, we can store it there efficiently, and then the UI will be able to pick it from there. And then it will get a notification that say, hey, there's new data somewhere. Okay. So hopefully that makes sense. And then I'm going to show a little bit how I did it in AIPack CLI. So this is a little bit confusing here because now we have two things. This is Zcoder Rust, and that is the AIPack CLI. So now on this guy, if you look, and this is a monocrate. Okay, I should have split it earlier, but now it's getting quite a bit of work. And we have the model. And so this is the architecture that I like a lot. And in fact, this architecture is what we have often. If I zoom out here, is this kind of architecture that I've done for the Awesome app, the Tory app, or the Cloud app. They're all the same. It's always the same. It doesn't really matter if it's client or not. Yeah? You always have this kind of model. So the model is what the people, the other guys are getting, TUI or whatever. And then the store is how you store it. So you have this kind of architecture. And that is where I have the architecture of backend model controller with a model manager, which basically knows how to store stuff and all of this shebang that we had in the Rust web app and so on. So every time I create an app, and in fact, if you have a CLI app, if you have a desktop apps, if you have a mobile apps, if you have a cloud apps, it's always the same kind of architecture. The only difference between the cloud app and the desktop apps is that in the cloud, you distribute things across processes, across servers even, or VMs, pods, and eventually even nodes, meaning hardwares. Usually in the local things, you are going to have everything in a single process or couple of processes. So when you start Chrome, you have a couple of processes. You have the Chrome guys and the Chrome helper, and they communicate. We might have that in Zcoder at some point. But at the end of the day, it's the same thing. You want to decouple your backend from your UI. If it's too coupled, you don't scale. And then you have issue of performance. So that is what we want to do here, is to decouple those two guys. And so we want to have these kind of things. And everybody that have been watching my all videos and everything, because I coded a lot, I put on pause a little bit the videos, but I coded way too much for my age, is you will see that I have the same thing. So a run is a run of a program. So it's a run, it's an entity. But you will see here that, and that is not Zcoder yet, it's AIPack code here. But you will see that I have all of these types, and then I have what I call the backend model controller, which has a struct, and it has a table, the entity type or whatever, that is for whatever reason, and then I have the CRUD stuff there. And then sometimes I have some specific, like for run, I have get UIDs and list for display and all these kind of methods. So that is what we're going to do, because now this is going to allow us to separate, the things that I like to say in this video is to separate the separate the data store from the TUI state. So we're not going to send that down. So what I want now is to create this store business. So I'm going to go to this core, and I'm going to create a model guy. That will be my model data, which will have inside the store. So we're going to create an organized store. And that will be the store. And so the store will have more probably the SQLite kind of things. Or at the beginning might be like a vector with a lock on it, just to be safe. And then we'll swap it over there. And so now what we could do is we're going to do, here we're going to do a new mod.rs. And then the things that I like to do, and I'm going to kind of pick up a little bit. I might do that to not confuse too many people here. Do that there. Actually, I'm thinking, perhaps we can go directly. What about going directly? Yeah, let's do that. Okay, we're going to go directly to SQLite. We'll give it a try. So what I'm going to do is I'm going to go there. I'm going to quit this guy. I'm going to go there, and I'm going to do GSC next store or model. Okay, so NX for next and model. So that is what we're going to do. That is my AIPack. I'm not running. This is yesterday. We ran for $4, not too bad. And then I did one more run this morning, I think. Not much, because everything was coded by hand. And again, the benefit of coding by hand is that if I would have asked, I mean, the AI wouldn't have been as smart as Xvoid, okay? These like little things, it will have looked at the error and it will like, went on, and it will have solved the wrong things and do a kitchen sink. And in fact, the fix was so simple once you understand the issue. And I knew yesterday that it was something relatively simple. So all of that to say that we're going to, so we have our branch. We're going to create our mod. So that is, I'm using Z here. So this is a section here, module. So this is my best practice. And then I'm going to have a mod DB. So that is the way I have it there. I have the mod DB, which is store, is the same thing. Yeah, you can call it the way it is. Mod DB is good. And now in mod DB, so what I'm going to do is go to lib, and I'm going to bring a model. And the reason why DB is inside model is because I don't want DB to bleed out. I want the DB to stay in that guy. So this is what it gives us. So I'm like such a big fan of the module model of Rust. Because for example, here, I want the outside world to just have events. I don't want them to have a distinction between MPSC or whatever, because my names, that's my agreement with myself and with the AI and everybody that writes codes, is that all of the names of all the types below, public ones, are going to be unique anyway. Because I want to have good name. I don't want to, rely on the package name. So that is going to be my strategy for this event. So now I can flatten these guys. So I still have organization, but then from the outside surface, I control it 100%. And then also with Rust, I can say, hey, mod, but this one, I'm not going to expose it on the back. Yeah. So the children always have access everything to that the parents have, and the parents have to make pub if they want to access. That's the way it works. So we have the DB. Here we don't have a mod. So right now, I don't want to bug you too much, but we're going to do that. I'm going to copy this guy. So the first one is going to be our mod.rs of this guy. This is going to be saved. So we're going to have the RT DB setup, and we're going to call it DB setup, the DB implementation, and then we're going to expose the DB implementation to the parent. But then the parent, which is model, won't expose that back. Okay? So now we have this, and we're going to save that guy. Now I'm going to have this file, and that is going to be our DB setup for now. And the DB setup will have this. And then again, this is the AIPack business. So there's a lot of things, and we're going to trim everything. But that is what we have right now. So we're going to use SQLite, and we're going to have a result. So often what I have is I have events error for most of the crates. Sometimes when there's a big submodule, it has its own error and result, and therefore result. So like this is a cleanup pattern, yeah. So you can scale. So by default, it's the parent, and then sometime when you have a big one, which is model, is going to have its own result and error, which is a good pattern, yeah, for these kind of things. So right now, I'm going to do the DB setup. I have that. We're going to fix the things later. And then I'm going to have the DB implementation, which we can fix later. So this one, we do that. Oops, sorry. DB implementation.rs. And I don't call it DB because Rust Clippy doesn't like Inception when it's the same name, which is fine. Those one are the ones that are private. I did this notation at some point. I'm not too excited about this, but I can change it later. And so that is all of those functions, but then obviously it doesn't compile because we don't have the rest. So can go to ML, and then on the DB side, we're going to use two things. So the way I like to do it, we're going to go back. So it's a multi-crate. So one thing I'm going to do is I'm going to follow that. Everything is going to be in the cargo root for now, in the workspace dependencies. And then people can say what they need after, above. So we are going to add something somewhere. Let's put it above the file. And that is the SQLite version with everything that goes fine. And the modql, and that is a long story, is a crate that I'm maintaining as well. And that allows us to have it's not an ORM, but it allows us to have a model view of, has some utilities on types to go in and out of the database. And it's at the lower level. It's almost as a SQL builder level kind of things. It can integrate with CQuery, but right now we're even going to use it without CQuery. So that is the two guys that we have. So now that we have this, why does this guy complain? Oh yeah, he complains because I didn't put it. It's a subcrate, yeah? So I need to put that. So I'm going to keep the symmetry over there. And then we're going to have DB. And we're going to make that as SQLite. And modql. And by the way, I don't know which one is the better strategy. Is it when you have something only in one crate, do you put it there, or do you put everything at the root? I go back and forth on that. I'm not 100% sure one way or the other for now. And then we have the error here, which is fair enough. And then we have the error here, and then this one is a DB def, and that is a recreate DB. So right now in AIPack, the SQLite that I'm using it in the in memory. So that's why when I recreate DB, I don't have to do any migration stuff. It's just in memory to make sure that the data is managed correctly. In Zcoder, I might move that into a real kind of file, such as is faster, but then caching needs to be pretty good quality as well. So that we're going to do that. So now that we have those two guys, we are going to do the following, which is going to be, where am I? This one, okay, we're going to do that guy as well. So we're going to do the error and result to do. Okay, let me give 1 sec. This is good. So I'm going to use that, and I'm going to do a mod error. And my best practices, pub, use, error, tab, or I can say result error. data like this way. Then I go back here. That's guy. So that's my best practice. I have the thing over there. And then this, I have the result, which is for that guy. And this is my way to say I don't want to think too much about stuff. Eventually, I might change that. If we do that, what does it do? Well, we're going to keep it this way. We'll see. And yeah. And then that's it. I think I'm going to keep it this way. That's good. That's good. And then that guy, create model error result. Why doesn't reload? Okay. Okay, so that was a leftover. Oh no, it was not a leftover. That's fine. Okay. Ah, that was silly. Model error. So I don't need to have it in the model over there. Okay, so now we have this guy. And so I have my DB over there. And it's compiling pretty nicely. So that is a start. So nobody is using anything. That's fine. And then I want to create my... Okay, this is pretty cool. My model manager. Interesting. I'm going to go there up. So my model manager is my state a little bit that I pass to create the data. So I'm going to do that. And obviously it's not that. So that is going to be that guy. So I do the model manager. He owns a DB. When I create it, he creates a new DB, which is the default one, and he recreates it. So right now we're going to assume everything in memory is fine for quite a while. And then we'll make sure that we do it on disk. But that simplifies a lot and provides already a lot of value on our app. So we're going to do that. And then we're going to have the DB. That is my stuff. So I need to think about what we want to do. And I'm going to actually have something like, we're going to simplify it. We're just going to have run. And we're going to have something like that. DB page, that's pretty cool. We're going to have in the app today. This is pretty cool. Look at that. If I do a Shift M, it will display the memory that it takes and the database memory that I have inside memory. So that is a nice way to know the stuff. So that is I like it. That is AIPack, yeah, but we're going to, the goal here is to take the best of AIPack. So we're going to do that. And then we have the pragma page size. That's good. And then, yeah, even if people don't use it, we don't care. Then Tokyo one cell. That is an interesting one. I think we shouldn't use that anymore. One model, return a reference of the singleton on the first call. Well, now we don't need to do that anymore. Why? Oh, because it's async. We don't care about async. I'm trying to think here. We don't care. Oh, we care about async. Oh, I have a new here. So here I need to know if I need to have async or not in this thing. So if I have a new async, but I don't think anything is async. Okay, that is a good example. I'm going to tell you why I did that. I thought sometime when I talk to database, my go-to is to go async because in case it's async or remote. So I think this is where I want this way. I think we don't need that anymore. So that was a way if I wanted to have the thing, I think. So I'm going to assume that we don't need that, and we're going to do something like that. Okay. And so I'm going to stay. There's something in your runs hard to do. So I'm asking ChatGPT right now because I'm lazy to find the right pattern here. Use a new static. They have a static or standard. I don't remember what it is. So something like this. And I don't want to confuse it like this. I'm going to remove it. I don't want to think that is async. I don't know if it's going. There's a static way of doing it. There's a new way support. So we're going to try to do it the new way. No, it's an epic fail. No, Rust static standard. I use it somewhere. It's a once lock. I always, with the one source and once lock, I always confuse. Yeah. I think this is this. I'm a little bit lazy here. Once lock new. Instance, once lock, yeah. Interesting. So in fact, if we do that, okay, that's fair. We're going to do that, but then we're going to change it a little bit. We're going to do that. But then the new guy doesn't need to be public. Yeah, because I say get, and then that's it. So I think I'm going to do that way. Try or init. Okay, so get or init. Okay. Res. I don't understand then. I don't understand how this guy is doing it. Okay, 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 I get it, I get it. This needs to be result. Yeah, that's it. So that is what we want. Okay. No, we'll get it. Huh. That is interesting. That is a result of manage. I don't want that. Oh no, that's fine. And I don't want, I'm not going to do unwrap or whatever, because this unwrap stuff is pretty bad. What does it do? This self-db get, okay, static, model manager, instance, new. Yeah, why I didn't think of that? Oh, no, 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 I don't want that. Interesting. This is a weirdo thing. There's something I'm missing here. I don't like that, but I'm going to do that. So I don't like to have my error implementing clone, but I'm going to do it here because I don't want to spend too much time on that. Oh, yeah, but then it doesn't clone. Okay, that's fine. I'm going to do something like, so this one has a custom. I'm going to do a little hack for now. So I'm going to do something like this one. My get is going to be std result standard manager and a string. I'm going to use a string as an error. And then I'm going to say toString. Not good, not super good, but good for now. Okay, so we'll do that. And this one we can remove. I'm not super happy with that, but it's good enough. Yeah, so not should have on error string, but it's to be clone. I think I almost prefer that than having the clone on the other guy. But we'll see later. So the new here, so this one is a clean result, and then this one we are using result with a string, so that will be good enough. So the trim delete, that is a trim database, that's the DDB size. So that is management business. I like the multiple implementation like that when I goes more. And then I have a mock seed over there. And that means that I have a run BMC and run create. So that we're going to run for create. Okay. And then I'm marking the stuff. This is pretty cool. So what we're going to do is, and today I have to go at 3:30. So we have 33 minutes. So today what I'm going to do is I'm going to create, so I have this, I have the DB setup. And now, so that is for my other app, but we're going to create it like this. We're just going to have prompt, which is a user question. And we're going to have the answer. Which is an AI answer. So right now I run, we only have that. I'm going to keep these two guys. I always like to have that as a thing. This one we're going to delete. That is all AIPack stuff. We're going to remove that. We will. Oh, we can. No, we're going to remove that. Remove that. We're going to keep the model. Remove that. We're going to remove that for now. And then that's it. And I think it's SQL, so no comma there. So that is the DB setup that we'll have. And then create schema and create schema, and then this one. Oh, it goes through all the main table. Okay, that's cool. So like this is like pretty generic. So I have my run table. Task I don't need for now. We'll add those. I mean, we'll add what we need later. I don't want to add dead code. There's a lot of things here that we're going to do then. So my main table is only this guy. That's my way to like create. And then this one, we don't need. So we don't need that the support. So now it's going to complain somewhere over there. And I think it's fine if we just do like that. Okay, okay. We're going to keep it like this. And you content. Okay, then we'll do that later. So that is pretty cool. It's some things that I've done in, and we're going to do that as well. In AIPack, which is basically, there is a unified content. So it's a hash, and then for the content. And then if there's two big content that is the same, then you always go to the same table. And then everybody point to this uContent table. So that is pretty nice. We'll do that later. That reduces quite a bit of things because sometimes the prompt is the same or the answer is the same or whatever. So that is safe. The prompt usually is the same. And so that's good. And sometimes the content can be the same as well. So now we have the run BMC and the run for create here, which is actually pretty good. And what we're going to do is our guy here. We're going to allow the user don't like this error. And then we have to have these two guys. So on these two guys, what I like to have something like that. Mod entities. Oops. And yeah, this is all my entities. I don't have a better name. I need to find a better name on this guy. Then I go to that. Modules, this is just my best practice. And then, so we're doing Rust, we're coding for the new guys here. Sometimes there's people come stuff. We're building Zcoder from scratch. It's a new AI parallel first coding agent, coding harness. And we did the event model. We're on the episode 04. and then we are doing the data store. So we are splitting the data store from the TUI state. That is what we are doing today. And we are coding it by hand to start with, because one of the things here, and I said that yesterday, yeah, the trick in the AI coding, production coding now is always with AI, because we need to use AI to force multiply ourselves. But the goal is, what is to code the 10% or the 20% that put the AI in the right track, the right patterns. There's different ways of doing that. I could have, for example, in this case, I could have extracted this from, it's here, from the AIPack. This is the AIPack code. And I could have said, hey, cherry pick this and copy it there and stuff, but I'm doing it by hand, because sometimes when you do by hand, you clean a little bit more and you take your time. So sometimes it's good to take your time before to put the thing in the right track. And then when everything is aligned, everything is going to go well with AI. So for example, right now, I'm going to cherry pick those guys, the run. So the run in the AIPack is much more complex, but in this case, it's going to be very lean. So I'm going to go back there. And I'm going to copy, this whole thing. Well, actually, the whole thing. So mode, we're going to say a mode run. And we are going to go in the mode. The goal is to do a pub run that will export the run. Because again, I don't want the people outside pub use to worry about the sub module, because it's always going to be on unique names anyway. So I go to a run. And a run in my case is, in this case, is a run with AI. So when it's a run of a program in a way. So there's a program with AI. Today is a very dumb, a prompt and an answer. That's it. Later, a program will have much more into it. Call it an agent, but I think program is more accurate. Now you go there, I'm going to copy paste this whole thing that we had, and we're going to go through it and completely clean it. So that is interesting. Yeah, this is pretty cool stuff. So I'm not going to delete that actually. So the end state things, we don't need that. The ID, the model manager, we need that. The result, we need this. And the stage and running state, we don't need that today. Yeah. So now the model manager, why it didn't have it? This is because I have model manager, but I need to re-export it. So public, use model manager, and where do I want to be safe? Okay. So now I have this. I'll go back there. Up. So that's good. So now the ID, I like a lot the ID and stuff. Oh, I'm going to have to carry that over too. I like a lot the ID. ID means that every time I have run, it's an ID and it's a wrapper on top of I64. And so that's nice because I make sure that that is an ID. Eventually, that could be actually a UUID and blob. I'm thinking about it because with SQLite, if we use UUID v7 as the primary key, then it's very powerful because we can split and merge database, which is not possible if we use ID like that. So that's why I like to have a type like this. And in fact, let me go like that. Let me see, actually, I'm going to go a little bit brute force here. So I work the way that I will work if I were alone, okay? So up, I go there, I'm going to copy that. And this is all of the mess I've had. So AIPack US is a way, it's I64, but it's a way again for me. Rather to have I64 everywhere, I like to have this wrapper types. And it allows me to have this type that wrap I64, but is very, very focused on the stuff. So, and that should be something there, but we'll see. Okay, so now what I want is we're not going to have content for now. The end state, we don't need it. We need AIPack, we need that. We don't need model event. We don't need the run step, stage, stuff. And my goal again here, I just want to make sure, I'm focusing on that. I want this, and then when I put everybody on the track, I'm going to scale it with AI. So that's the point. So now what I want, I have this guy, that could be, and I'm going to show you, I love to use a new crate, which is, I'm going to show you. This derive alias, what is that? How come I don't find it? Okay. Oh, it's macro rule attribute. This is a very cool thing. So it's this guy here. I'm going to show you that guy. That is a pretty good guy. And that allows us, I did a video a while back for it. Creates this macro rules. Is it that one? No. It's macro rules attribute. What? Oh. So it's a macro rules attribute. It's a little bit a weirdo name, but it allows you to have derive. Like when you use their derive, you can compose your derive. So it's pretty useful. So one thing that I like to do is I'm going to put that there, macro rules. And then where I have my derive business, I'm looking at the code here where I have my derive alias. Okay. Yeah, okay, cool. So I'm going to put it there, but then after I think I'm going to do, so my pattern is I put like this, and then I put a mode, derive alias, says, and then I go like that, and then I put this. So that works beautifully, and then workspace, and then I say workspace equal true. So that will basically say that now I can use that. And so now I can compose derives, because otherwise, you have this long derives forever. So often for ID, for example, is a good idea. It's a good example. I want to have all these things because it's a scalar struct. So there's a lot of things that I don't need to overthink. Yeah. In fact, this one, the as could be almost something else. But and then the for this one, I don't know why. Oh, the ref wasn't implemented by default. So that is what I implemented. These two guys could almost. I could almost have my macro somewhere to develop these kind of things. But that is my scalar struct. So this way, if you go click here and you go to aliases, that allows me to have all of these things that now it's behave like a number. And it has that as well. So it simplifies so much because now I can see that is like a group of things. And so my best practices is you could say, use macro derive, but then you don't know who is what. So I say MRA. It's not the scary name here, but derive and then debug and scalar. So that is a little bit the thing I'm doing right now. So this way I have that, and then when I'm back here, same thing here. I have scalar struct, and then this one becomes the way I want. That could be one of my proc macros somewhere. I could have some things that does this automatically. I think the as wasn't there, and the from, wasn't the way I want it. I think there should be a way to have a from. I don't know. Yeah, but anyway. So all of that to say that works pretty nice, and so that is my type. So now the cool thing is when I am on run here, I have the UID stuff. Yeah, okay, let's put the UID things. I'm going to put everything. And again, once I have all these kind of things, once I have all these kind of things, it goes much faster. So cargo XML, because the AI will help a lot. So that is the thing. So that is critical here. All of this is very good to have. And then I'm going to do the UID over there. And so that is solving that pretty nicely. So now we have the run. And now the run entity has, so we have that looks pretty nice. We don't have that guy in the database. We have that. I don't think we have UID actually. Did we keep UID? Yeah, I keep it as UID. To not unique identifier, which could be anything. And then prompt and answer. So far, so good. So we're going to go back to our run. And then we're going to have prompt and answer. Answer. Okay, so that's good. Then the run for IDs. I don't know. Why not? Yeah, okay. That gives us the UID and stuff, but this might be merged. So that's why we're going to keep it there. We don't have the parent ID, so it doesn't make sense. We have the run is done. We don't have that anymore. Doesn't make sense. The create here. So that is a way that I do my backend object. If you guys have followed some of my tutorial, code, running state, we don't have that. Eventually we'll have. And so here's, we want a little bit more down to what I wanted to do, but we set up the SQL database today. And then the base stuff. So that is actually pretty cool. So I'm going to take that. Yeah. And I'm going to explain a little bit what is that. Okay. Okay, so we're going to put that there, and we're going to do BMC. Okay, run for ID, staff, run BMC, and then staff, and then entity type. So that is interesting. So it's an enum. So I had an enum at some point. Interesting. The entity type is part of my model event, which is I'm going to keep it there for now. So this is actually pretty cool. So what I have here is the way it works is the model thinks when something is updating a model, the model layer will trigger an event in a hub or in a broadcast or whatever and say, hey, this data, this type of data here run with that ID had changed, has been created, has been updated, has been deleted, or has been, whatever modifier thinks as a function we want to have. So that way, people, the web apps, the TUI, or whoever can listen to that and say, hey, let me know, when things is happening. So that is a way, again, it's another event way, which is probably more a broadcast way, where this could be multiple listeners say, hey, I want to listen when something is changing. And again, we are not sending the whole data there. If people want to know, the data, they need to query it again to the server. So that is the way it works. So now, one thing I have is this guy, which is actually, and for that, in my model event business, I need this action, which is created and everything and deleted and so on. And that is a whole other business here. I'm not going to go too deep into that. Well, I can go a little bit. That is a trick. It's very powerful. It's a trick to say, hey, this event has been updated, and here's the related IDs. And then you have IDs per entities. It looks like a little bit a hack, but it's actually very powerful because now you don't have to understand the whole hierarchy, but sometime on the TUI, for example, I am on run. And so if something changed, I want to update the run. But I don't need to know all the hierarchy. I just want to know, is there something that changed about the run? And so with that model here, I can say, oh yeah, something changes the task. I don't know how is it related to run, but it's related to run. So then I can check that, guys, which is in my event somewhere. Yeah, so in my model event, I have the related IDs. So that is I have the ID, the entity type, the action, the ID of the entity, and the related of the entity. But it's not the business. So I don't give the tree because I don't give the data, but I get the related IDs. So like this, people can listen, can say, okay, task, I don't do task, I don't know task, but I know the task is related to run ID. This run ID, do I need to update it or not? So that is kind of a cheap way of knowing if you need to update yourself or not. So hopefully, stuff. Hey, the Babooner. By the way, Babooner, you are going to be happy here. Here's the thing I did for you. If you go to prompt default, proof, look at that, user template. So just said commit, you can change it. Don't change that because you are going to break everything, but you can change that. And then you have the template for the plan, for the rules, for the spec and everything. The chat today still put that in. So it's stuff, but you can customize everything. So hopefully that is what you wanted on the AIPack. Yeah. So now that we have this entity, yeah, that was a good idea. It's actually someone else, one of my clients asked that as well. So I was like, oh yeah, okay. That was something I wanted to add for a long time. So sometimes I wait until someone asks. Then I do a mod type over there. And the question is, yes, I'm going to flattening out, use types star. I'm going to flatten it out. I don't need to have all the detail. Scalar truck. Oh, epic fail. Okay, that's fair enough. There's a thing here to do. Okay, I'm going to have to go soon. Yeah, that's good. Yeah, so that is a whole run. So you know what? I am going to remove all of that. Those are specific ones, so I don't need. I don't need that. I don't need that. I'm going to remove that for now. It's not. Get, and we don't need a wait anymore. Cool. That is what we fixed just before. Create. What does the create has? Run for create. Okay, we didn't do anything here. So we are going to have those two guys is not of the create business. That guy is not of the create business. It's only that. Yeah, because that is part of the under stuff. Then on the update is the same thing. Let's allow to update, but we might not allow to update. And so now I have to have Tokyo. Okay. So now the one question is SQLite is not async. There's no value of, for SQLite, there's no value to do async. So the reason why I did the async in the AIPack is because if one day you want to go to a normal, external database, then you will do async. So that's why, it's always tricky. It's a little bit of waste to do async there. But at the same time, if you don't do async, then you're like locking yourself. Then it's much harder to walk back. So that is why it's always a little bit the tricky here. So I'm going to keep SQLite, this stuff, not async, to simplify things. And then we'll see where we go after that. Okay. And then I'm just going to do a create right now. I don't want to do. I just want to really have the minimum because I don't care about anything else. I just want that. I don't need time. I'm going to do prompt. Why is sky red? And then the answer because I'm not happy. Okay, and then we need to do these two guys. Oh, epic fail. That's fine. I'm very happy about that. But okay, so that's good. Why this one is get here? It's not new. So we don't need that. We don't need that for now. This is where I like it. I take my steps there. I never know if I need to have that after or before. I don't know. And then that's it. That is not granted, but whatever. So that will be my test. This is base. So now I have to have base business. So mode run. And that is model base. And the reason why is that because in base, what we have, if we have the CRUD function. So the way we do, the way to do inheritance, you can do a type inheritance this way. So you pass a type in this turbo, in the generic things in a way. So that's the way you pass type to a function, which is actually create a new function for this type. But that semantically is what you do. And then you have your model manager and the SQLite fields, which is a ModQL stuff. And then you can have all of that goodies. So now I can do something like this. And I'm going to do, no, I'll go to model here. I have the DB. And in model, I want to do the mode base. Now, again, in Rust, all the children have access to everything that the parent has access to. So he will have most of it. So now he has a create support here, time now macro, which is fair. So let me see. Okay. Oh, that could be a ZC command, I think. Let me see how I do from a meeting standpoint. Am I missing anything? No, but I have very few minutes here. So I'm going to try to do that. And then the support, so that is pretty cool, is a no macro. So I have this time now that return a macro thing. So I'm going to do that. And I'm going to quickly try to find it in my support. So time. Okay. So I'm going to do that. And that, for example, is a good thing. So that's the way I had it in AIPack, but in Zcoder, I want to go a little bit better. And that should be a Z command. Okay, Z command. And it could be time. Yeah, that's fine. And then it could be stuff. So now we're going to go to our Z command over there. We're going to add a mod time. It's a little bit on the root, but that's fine. Do that for now. Pub mod time. And we put everything time there. That, and this is going to be that guy. And then it's going to cry, I guess, time. And then we are going to add the type, which is my time type. That take care of the time zone and all these kind of things. Plan. This is going to be that, and then we're going to be here. Fail, and then we do this. Workspace equal true. Okay, so now we have that, and that's pretty nice because it's expose the time. So again, taking your time to do that, and then we'll use AI. Not to worry. That's pretty cool. Oh, but I don't know why it doesn't complain more over there. Oh, because it's kaput. Oh, that's funny. Did I break? Sometimes it does that when you break the cargo build. Zcoder rust, fail to manifest dependency, fail to parse, yeah. So sometimes when it's kaput like that, it's because it fails parsing. So I broke something. What did I break? Okay, and someone can... what? Oh, that was done. I don't read the stuff. I put it in dependencies. Why did I put it here? Where was that? I got confused. Sorry, guys. Up. Put it in the wrong guy. Oh, that's a lot of errors, but that's fine. I'm going to have to fix that offline. Model scalar struct. That is fine. Oh, there's not model here. Where was my derive alias? Is a great business today. No? Uh, why? I had some time with macro is annoying. There's something here that needs to happen. Derive alias. Oh, I know why. I know why. Because I was relying on that two guys. Got to put it there for now. Because this one here, you can compose them, which is pretty cool. So I will find a way to put that into the common. Those should be ZC common. And those should be almost model or core for now is fine. But those compare and enum struct, those two guys are the stuff. But now this one I'm going to, because we don't have strum yet, so I will add that later. So now I should be almost. Yeah, the ID doesn't stuff. He is human. Yes, I'm definitely human. That's definitely not AI, guys. So I will do So that's my SQLite. So that's fear and stuff. There's a lot of really cool stuff there. But this one is not taking that because I have my derive alias here, which is, I don't know why, is not being more friendly. Use stuff, okay. And I think I know, because I didn't do that. By the way, that shouldn't be pub use. Cool. I would say use derive alias. I only want to use it within this guy. It's annoying then. Yeah, this is something I don't really like, but whatever. So that is a thing. And so now, what does it still complain over there? Oh, fair enough. Okay, now that's good. Now this guy still complains somehow. Cannot find deref in derive mode. That's fair enough. And that is because the way that derive mode works is you have to have those guys, and I don't think I have everything. That's the benefit of having the cargo business. I'm going to add all of that. This derive mode is very cool. It's a guy on my Discord that told me one day. I don't remember his name. Const. Oh yeah, I have. Oh, look at that. Oh no, okay, 15 still. And I'm going to have to go soon. Support const. What do I have? Whoa. I'm going to remove that. That was the only thing that I have there. Hub. Get hub. We're going to remove that. So the hub was the event here, the kind of the broadcast. I mean, then after it wasn't a broadcast, but I want in the model to have a model hub in a way, or bus that people can subscribe, broadcast. Yeah. So the goal is that many people can broadcast and say, hey, I want to listen to X, Y, or Z, or at least I want to get notified on things. So that is one thing that needs to happen over there, is to be able to be subscribing to things. So we'll build that, and that is very important because that's the way that the model layer will tell everybody else, which could be the TUI or stuff, because again, the architecture here of the Zcoder is that guy. Yes. So what we want is a core here. The core will have the store, and so the core will kind of emit event every time something is changing. So the UI say, hey, here's a prompt, here's a command. Then this guy does the work, and then it will emit things back to whoever wants to listen. So if one day we have this web and this TUI, they will get the event back, not the whole payload. Yeah, the goal is to not move database around messages. Yeah, that's not the goal. The goal is to say, hey, this ID has had changed this way, create, update, or everything. We don't need to keep the delta. And then we say, here's the ID, you can go and look at it. And then people decide if they want to look at it or not. Yeah. So that is the way it's going to work, and that's why we have this architecture. So in fact, if you go to the base here, you will see that the base is a way that you pass types. And the type here, if you go to a run, I still have the compile. I'm going to fix all of that. I don't want to bug too much, and I have to go. But the run here will have this, has a type. And so that is the one that you have the run BMC over there. And all the run BMCs or the DB BMC have the table and the entity type. And so with that, the CRUD FN knows to say, oh, that is a model controller. That is a DB BMC. And then it can assume, it can find the table. So we can see that here, it can say, hey, just give me the table ref. And then that, it comes from the fields that we can extract. So when you do a run, you have this type, which I think is what is crying a little bit here. These guys, and I need to have the right import here. But you had this guy that basically will make this field, such as you can take the field out, the value not known and all of that. So that is the way it works. Yeah. So that is the things. And I'm going to do what I'm going to do, and I have to go. Right now, there's a lot of compile issues. What I'm going to do is I'm going to push that to as an NX model branch, and then I'm going to continue to work on it, or perhaps a live, or I will work on it, fix it, and then tomorrow we'll do tomorrow after tomorrow we'll do a review of the code, of that code that will work, and now the run and everything will run into the database. So like this, that will be the next step. So I'm going to do a git log to see where I am. So that's the clippy clean name. So now what we're going to do is we're on the NX model here. We're going to, so usually I don't like that. I don't like to commit when it doesn't compile. I don't do that. So I'm going to do a git c, something like that, and say prep halfway through first run db entity. And I'm going to do a GPO, it's going to complain, and I'm going to take that guy. And if you go to bonsoir, I hope you're doing well. Yeah, as you know, little by little, we're making good progress. It's going to be, right now, it's still a secret project in a way, but I think once we're going to have the Zcoder working the way I have in my head, is going to be pretty powerful. And now the interesting thing is, I could have done that with AI, but I would have missed important point, some of the cleanup here, because I will have copied the thing from AI, will have taken too many things from AIPack, and I wouldn't have taken time to complete all of that. So it's always this kind of things where what you want, and today and yesterday even, we did quite a bit of that, as to really take the time to put the thing into the right track, to have a good code base. Because once I have that thing set up, once I have this thing set up with the alias and all this business, then the rest is going to go very fast, because it's like, hey, follow the pattern of run, and now I want to add this, now I want to add this enum, now I want, and it's almost going to go super fast to add everything. So that is a little bit kind of a secret sauce that we real programmer can have compared to coders and pseudo CEO, CTO coders or whatever. We can actually optimize much more this 80% stuff than, because we take care of that. And so, and we can learn. I mean, I could have used AI to do a little bit and then change this different way of doing it. But the point is, you want to own the engineering, the starting track. So that will solve these kind of things. And I think oh, sorry. I actually did a mistake here. Git add, because I didn't add anything. Git amend, I'm going to do a git push for sure. That's not good, but that's it. Okay. So all of that is not compiling. This is why I do a git log and it's in a branch. I don't like, usually even in a branch, I don't push things that doesn't compile. But right now I need to go, and in case you guys are curious, you can goof around with stuff. But anyway, thanks a lot for being here. Hopefully that was helpful to some, and we'll continue to do this kind of live coding. For me, it's good. I like to do that online, and If you have any questions, feel free to ask. And also feel free to ask questions in the on the YouTube things, by the way, because I mean in the live you can ask questions, because in the next video I can answer the good question. And often there's awesome question stuff. So if you are missing the question here, make sure to add the question in the video, such as I can see it. And next time we'll do these questions. And I do those live because this way I have less editing. At some point I want to start again doing the other videos, but there's more editing. Every time I say, oh, I'm going to spend only 30 minutes editing, and then I spend too much time editing, and so I need to find the time to do the other ones. This one I have to do the work, and I just want to share. Okay, so see you the next one, and until next one, happy coding.